Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope you all are doing really great. So students, in this video we are going to learn about the cells, and in cell what are the important terms are there, you can see very well. EMF, internal resistance and terminal potential difference of a cell. Now the question arises, what is cell? Okay, so you can see very well, a cell converts chemical energy into electrical energy. In this video we will learn about the electrical energy, but what is the chemical energy? Maybe in chemistry you have seen there used to be the two rods. One is the anode rod, that is positive, one is the cathode rod, that is negative. Both the rods we put inside a electrolyte. Okay, so this forms the cell. Much more detail you will study in electrochemistry. Okay, but as of now remember that here anode rod, cathode rod and electrolyte. Is it? Okay. Now students, we are going to see what is the electromotive force. The short term is the EMF. Okay, so see the definition. The work done by the cell in the flow of unit positive charge in the whole circuit including the cell is called the EMF of the cell. Okay, now if we write here mathematical form, you can see here, if work done by the cell is W during the flow of charge Q, okay, then EMF is what? As you can see in the definition also, work done per unit charge here. Okay, so here students we can write here this EMF formula will become here E equal to work done by charge. That means E equal to, it is coming here, E equal to W by Q. Okay, so can you see very well students? And one thing remember that here maybe in the term it is coming like a force, but it does not mean SI unit of the EMF is the Newton. No, SI unit of the EMF is the volt, or we can tell joule per coulomb also. Okay, you have to remember this. Okay, great. Now we'll see here some important points are there. So see the first important point, as I have told you, SI unit of EMF is a volt. Okay, and remember that here maybe you may think force term is coming, so it may be the Newton, but it is not a Newton. What is this? A volt, or even you can tell joule per coulomb also, as I have told you very well. After that students, here the second one, the dimensional formula of EMF is this one, ml square t power minus 3 a power minus 1. But here the thing arises how we will get it here. Okay, so you know the formula E equal to W by Q, is it? Because no need to mug up the dimensional formula, we should know that here most of the time. Okay, W means work, dimensional formula how much here students here, ml square t power minus 2, whether work, energy, torque, same, ml square t power minus 2. And charge means what is this? The charge is 80. Okay, so students, when you will simplify this, you will get this dimensional formula. Okay, great. Now students, some other basic factors here. Third one, EMF depends on nature of electrolyte and metal of the electrodes. Electrodes means, as I told you, anode and cathode. Okay, after that here students, the fourth one, EMF does not depend on the area of plates, distance between the electrodes and the quantity of electrolyte. And one more thing is this, the size of the cell. Okay, so this is the information is there. Kindly remember that here on these factors, that means in point number 3 depends, and in point number 4 on these factors it does not depend. Kindly remember that in a MCQ, AR and all they may ask somewhere. Now here you can see very well the internal resistance is small r. Okay, so see here as it is written, resistance offered by the electrolyte of the cell when electric current flows through it is known as internal resistance. Very simple, resistance offered by the electrolyte of the cell when the current is flowing. Maybe cell is charging, maybe discharging, that we will see that. Okay, but the current should flow and the circuit anyhow it will be closed. Okay, now students, some important points you can see very well. That means internal resistance. Okay, so it is directly proportional to the distance between two electrodes. Directly proportional to distance between two electrodes. That means I can write here R directly proportional to L, distance between two electrodes. Okay, second one we can see very well, see it is inversely proportional to the area dipped in electrolyte. Okay, that means R, this is inversely proportional to A. What is the A? A is the area. Okay, third one students, here you can see, remember that here, it is directly proportional to the concentration of electrolyte. Concentration, whether it's a more concentrated or dilute, all these things now related to chemistry term. And the fourth one you can see very well, it is inversely proportional to the temperature of the electrolyte. Okay, students, so these factors you should know very well. These 4 factors are there, remember that. Okay, great. Now students, we are going to see the most important thing, and that is the terminal potential difference V. Okay, so see here, when current is drawn from a cell, that means in this situation it is discharging, we will see, or current is supplied to it, then potential difference across its terminals, is called a terminal potential difference, or we can tell in a short form terminal voltage. Okay, so now friends, multiple cases are there. We will see discharging, charging, open circuit, short circuit. Okay, so all these cases we are going to see one by one. Okay, so see here, the first case we can see here, when cell is discharging through a load. What is this? When the cell is discharging through a load. Whenever we are telling cell means, remember that here EMF and internal resistance we have to draw here. Okay, so here the students, here I have drawn here one cell and its EMF is E. Okay, and internal resistance how much? R is this. Okay, and this is the terminal of the cell. What is this, students? This is the terminal of the cell. Okay, this is A, this is the B. We have to calculate potential difference across point AB. Okay, now what is this here? Here I will connect here one load. What is this here, students? Here I have connected here one load. Okay, so in this situation we can write here the cell is going to discharge. Discharge means what will happen right here? Let's take this is the positive terminal, this is minus terminal. So current will flow in this direction. Okay, like this current will flow. Okay, like this. So here this plus this minus, now because current is flowing in this direction. This is the discharging circuit. Okay, students. So here if we write here, now multiple terms are there, but the main thing is that the terminal potential difference, and this is the terminal potential difference. This is the V. Okay, even this V I can write here VA minus VB. What is this V? Remember that here V is the VA minus VB. Okay, so now we will see one by one. If in case I write here the first thing, the current flow in the circuit. How much, students? Very, very important, the current. So this current you can get by the applying the KVL also, but in a simple circuit, what is the use to apply the KVL? Now directly we can write here total EMF how much here? E, and this capital R and this small r connected in series, because in both of them current how much here? I. Okay, that means this I can write here, see here, E by capital R plus small r. Okay, this is the current. Okay, now students, after that if I will write here the second one, let's take here now second one. If in case we want to calculate here the terminal potential difference, okay, so here I can use somewhat KVL also. Okay, so okay, just I am using the KVL. So see here, VA, I have started from point A, I will take the second sign, that means minus E, again second sign I can write here plus I internal resistance R, where I have reached, I reached here at point B. Okay, so students, here if I write here, it will become here, see, this VA minus VB is equal to how much? It will become here E minus IR. How much coming? E minus IR, or VA minus VB, what I have told you, V. Okay, so here this terminal potential difference is given by, during the discharging situation, V equal to E minus IR. What is this, students? Here kindly see very well, V equal to E minus IR. Okay, even this V can be written in another way also. See here, if I write here the V, not terminal potential difference, V. So we can see here you can see the current is going I, resistance is R. So even we can write this V equal to IR also. What is this, students? Here V equal to IR also. Depending upon the situation, we will do that here. Okay, because see here also, see, when you will write here, when you will do the cross multiplication, it will come I capital R plus I small r equal to E. I capital R will become V, then directly we can write this expression V equal to E minus IR. But this is the basic way. Now we have done with the basic way. Okay, students. So I hope so. Now just kindly see very well how we have done it. Okay. And next also what we have got here, this one we have got here V equal to IR. And you know very well, even this we are writing from where, students? This we are writing from the Ohm's law. Okay, we know very well V equal to IR, is it? Now after that, if we'll see here the terminal voltage versus current graph. Okay, so here as we know that, very, very important, as we know that, see here, V equal to E minus IR, is it? This is the expression. From here question came, that's why we are seeing in a detail. Okay. After that, see here, if this equation I just compare with y equal to mx plus c. Now, y equal to mx plus c. Okay. So here we are going to draw here. This graph we are going to draw. See, the graph is going to be the v versus I. Which graph is there here, students? V versus I graph is there. Okay. V versus I graph is there. Let me draw here some straight line. No, somewhat straight line should be there. Okay. So V versus I graph is there. So if we want to compare with this, remember that here, this equation I will write like this: V equal to minus IR plus E. Okay. Now directly we can compare here. So you can see very well, students, here if I write all the things here, let's take what is this? Along the y direction, what we have to write? We have to take the voltage. Okay. And along the x direction, I have to take here the current, na? This V, this Y, this R. So little bit mistake happened. See here, this minus IR. Just make it here minus IR and here E. Okay. I will just correct it. Okay. Now okay. See, minus R into I. Now okay. Now, so along x direction, what is this? I. Okay. Next one is, students, here, if I write here the intersection, or we can tell intercept on the y-axis. So this C will come what here? If you will see that here, students, here, this is C, this is E. That means intercept how much here? C equal to E. Okay. And one more term will be there. What is that term? You can write here the slope, M. M will come how much here? Here you can see M. Here how much here? Minus R. In the exam even they have asked, okay, like how much intercept? E. How much slope? Minus R. And when the slope is minus, remember that here, students, here slope means, here the slope means tan theta. Slope means what? Tan theta. That means which kind of angle? Always obtuse angle. Okay. So based upon that, students, if I draw here the graph will come something like this. Okay. This is the graph during the discharging. Remember that very well. Okay. And here what will happen that here? This intercept on the y-axis, that means along the voltage is E, and this intercept will be how much here? This intercept will be how much here? E by R. This intercept how much here? E by R. Okay. And this one here, this slope is theta now. So we can write here, see, as I have told you, M equal to tan theta is equal to how much here? Minus R. Okay. And you may think that here, why I have got suddenly E by R. Okay. So for that, I will just tell you one more basic. You know very well what is this, students, here? V equal to E minus IR. Okay. So students, remember that here, line means 2 points will be there. If I write here, let's take for example, I equal to 0. I equal to 0 on which axis? On vertical axis. So when you put I equal to 0, what you will get here? You will get V equal to E. Okay. And here you have got here this point. This point is you have got now. So see, V equal to E. Here EMF E, that means terminal potential difference E, and the current how much here? 0. Similarly, if I write here the next one, let's take here for example, if in case on this axis, on this axis, how much is 0? V is 0. Okay. So here what we can write here, when V equal to 0, we can write here I equal to E by R here. That's why E by R we have got here. Okay. Students, so I hope so. Kindly see very well. This thing is the very clear to you. As I have told you, the terminal voltage is V equal to E minus IR. When I will compare, slope will come minus R, intercept will come E, and even this point E by R we have got from here now, because line means 2 points will be there. Okay, great. Now students, next one we are going for the case 2. And what is the case 2? When cell is charging by a battery V. When cell is charging by a battery V. So remember that here, this is the cell. Okay. This is the cell here. This is the E. This is the R. And now what is this here? Here we have connected one battery. One battery, or we can tell one cell, and its EMF is more than the EMF of the given cell. Okay. So in that situation, we can tell that here. Now this V is this. Now we are just taking normally ideal to keep the things simple. Okay. So what will happen that here in this situation, students, this is the plus, this is minus, this is the plus, this is minus. Anyhow here, the V is greater than E. Okay. So what will happen that here, students, here the current will flow in this direction. This is I. Here also I. And when the current is flowing in this direction, this plus, this minus, because across the resistance, if the current is going this side, that means this plus, this minus. If the current is going opposite direction, that means that plus, this side minus. I hope so, understood very well. Okay. And the terminal potential difference means here we can tell VA, and here we can tell, students, here VB. Is it? So now we'll write here the first one, the current. No? First one, electric current. So can you guess very well what will the electric current will be this? If you will think little bit, you will get it very easily, but okay. We can use here the KVL also, no problem, okay. So students, if I'll use here the KVL, I am moving like this, okay. So always second sign I am going to taking here, going to take plus V in this direction, then minus E, then after that you can write here the students here minus IR, and we reach to the same place equal to 0, okay students. So here what will happen that here we can write here see IR is equal to V minus E, okay. IR is equal to V minus E, hence I will be how much here, you can see very well, V minus E by R. This is the current, this is the current, kindly remember that, okay, great. Now students, after that if we'll go for the next one, that is the terminal potential difference, that is our main task. So again here by the KVL, terminal potential difference we are going to see start with the VA, okay. Second sign minus E, again second sign minus I into R, where we reached at point B, is it? That means we can write here, you can write here, see this VA minus VB is going to how much here, see E plus IR, okay. Or hence we can write here this VA minus VB means V, so V equal to E plus IR, okay. You have to remember that during the discharging, during the charging situation, it will be V equal to E plus IR, okay, great. Now students, after that we will see here when cell is the open circuit. What is this? Discharging we have seen, charging we have seen, now we are seeing the cell is open circuit. So here what will be this? See, very easy, this is the cell is this, now EMF E, internal resistance how much here, R, and here you can see very well, this is VA, no? And here we can write here VB, okay. And this is the terminals, and here what is this here students, remember that here we have not connected any load, okay, no load is connected. So this is called here which situation, open circuit situation, okay. And in this open circuit situation, you know what will be this, remember that here open circuit means resistance infinite, hypothetically, okay. So here what will happen that here, this is the plus polarity, this is minus polarity, okay. So if I write here the first thing, current, you know very well the current always flows in a closed circuit. Here the circuit even is open, that means current will be how much here, the current will be 0, okay. After that if I write here the terminal potential difference or terminal voltage, so start with the, okay, I am going to use here the KVL, okay. So we can write here, see by KVL, I am going to start from the point as I have told you very well. So VA, second sign minus E, here any drop is this, even the drop is not there, even we can't write plus minus sign also because the current itself is not flowing. That means in the resistance how much drop is this, 0, the current is 0, and we have reached at point B, okay. So we can write here the students, you can see VA minus VB is equal to E, okay. That means the terminal voltage is going to be how much, V equal to E, remember that very well, okay. The terminal potential, very important, when the cell is open circuit, the terminal potential difference is equal to the EMF of the battery, okay, great. Now students, next one, when the cell is a short circuit, okay. So see here, this is the EMF, this is the resistance, this is E, this is R, okay. And anyhow you know very well this is the terminal potentials, VA, VB, this R is the internal resistance because of the electrolyte, okay. And now what is this here students, here this cell is the short circuit is this, okay. And remember that here whenever the short circuit, let's take for example short circuit is this, short circuit directly. So in case of short circuit what happens that here, remember that here the resistance will be 0, the load will be 0, nothing is this, okay. But anyhow you can see very well the circuit is the closed, okay. So in this situation what will happen that here, this is plus, this is minus, so current will flow anyhow, this is I, and here also I, and this is the terminal potential difference as I have told you very well, V equal to VA minus VB, okay. So what will happen that here students, kindly remember that first if I write here the current, so electric current will be how much here, EMF is E, resistance is only R, so we can write here I equal to E by R, okay. And remember that here when short circuit will be there, the maximum amount of current will flow. Why? Because small r value is used with a very small, okay. So remember that here I max is E by R. If in case I write here the potential difference, number of ways are there, okay, but first I am going to write here with the KVL, okay. So see, I will start with the VA, then you know very well now, minus E, and the current is flowing like this, so this is plus, this is minus, okay, and I can write here, see, this plus IR is equal to VB, okay. So we can write here the difference here, this VA minus VB is given by what? E minus IR, is it? So now we can write here this V equal to, the value is E only, minus I, current I value, what we know? E by R into R, is it? So what will happen here, students? See, this R and this R cancel, okay, and it will become here how much here? E minus E. Hence terminal voltage is going to be how much here? V equal to 0, is it? Even this thing you can write with one optional way also, okay, one optional way is there. What? You know, I told you from the Ohm's law we can write here V equal to IR even, but here R how much here? Anyhow 0, so directly now also you can write here 0, is it, students? So I hope so this short circuit situation is also very clear to you, okay, great. Now you can see here we are going to write here the summary, because that is the very important, no? Because we may confuse, we have seen the 4 cases. So see the summary of terminal voltage. First one, when the cell is discharging. So discharging means, always remember that here, whenever the discharging, see here the discharging, this is E, this is R, this is the voltage terminal, VA and VB, okay. So remember that here, when the cell is discharging, what will happen that here? This plus, this minus, current will flow outward. Sometimes they have asked like this, okay. So the current will flow outward, and the terminal voltage, that means VA minus VB only, that means V is equal to how much we know? E minus IR. Now, and especially the graph that I have taught you, very important, okay, great. Now friends, if we see the second one, when the cell is charging, so that time what will happen that here? Remember that here, again if I draw here like this is R, this is E, this is VA, this is VB, okay. So during the charging situation, what will happen that here? This is connected to the battery, that means current will flow in this direction. Current will flow in this direction. So when the current will flow in this direction, remember that here battery polarity fixed, plus minus, but resistance what will be this here? See here, current is flowing in this direction, this plus, this minus. Upward situation, current is flowing B2A, that means this plus, this minus, okay. And here students, what is the terminal voltage? It is given by VA minus VB, means V is given by E plus IR. What is this here? E plus IR, okay. Now see here, when cell is a open circuit, so as we have seen very well, very important case, when the cell is open circuit, V is equal to E. Next one, when the cell is short circuit, so in this situation, what is this? This V will be equal to 0, because load is 0, okay. Open circuit means resistance infinite, short circuit means resistance 0. So remember that here, this summary of the terminal voltage, okay, great. Now students, we are going to see here, one question is this, see here the question, NEET 2022 question is this, now means actually the NEET 2022 one question came, that is very similar to this question, okay, I should tell you now. So a current of 2 ampere passes through a cell of EMF 1.5 volt having internal resistance of 0.15 ohm. The potential across both the ends of the cell will be how much? So students, after reading this question, the confusion arises whether this is the charging or discharging, okay. So remember that here, if nothing is very clear in the question, always take by default discharging situation, okay. So we can see one by one. See here, the current is given here how much here? 2 ampere, okay. EMF how much given here? You can see here 1.5 volt. Now see here, this is the 2 ampere here, and see here 1.5 volt is here, okay. And internal resistance how much is given here? See here, directly it is given here, this one here, 0.15 ohm, 0.15 ohm, okay. So students, you know very well here, see, we know that discharging situation means V equal to E minus IR, is it? So what will happen at here? Just put the values here. E means 1.5 minus current how much here? 2, resistance how much is this? You can see very well, 0.15, okay. So we can write here, see, 1.5 minus 0.15 into 2 means it will come here 0.3, and we can write here 1.2 volt. So which option is this? 1.2 volt. You can see very well, the option is this, option D, is it? So see here, option D, is it? Great. Now what I told you, by default discharging. Now NEET 2013 question is this, this question came, okay. So see, the internal resistance of a 2.1 volt cell which gives a current of 0.2 ampere through a resistance of 10 ohm, how much? Okay. So internal resistance and all they are asking. So let me write here. What is the data is given here? The internal resistance of a 2.1 volt cell. So 2.1 volt means E is given 2.1 volt. Okay. And current how much is given here? So I kindly see this current is given here. See 0.2 ampere. Okay. And they have given through a resistance. Now load is connected here. How much? So you can see that 10 ohm is this. 10 ohm. Okay. So here also discharging situation anyhow. So I equal to, as I have told you very well, I equal to E by capital R plus small r. Okay. So from here students, if I write here, see, capital R plus small r is equal to E by I. Now we are making just formula. So small r equal to how much here? E by I minus capital R. Okay. This formula we have got it now. So now we have to just put here the values. So if I put here, E how much here? 2.1. Okay. And I value how much is given here? 0.2 and minus capital R, that means how much is this here? Minus 10, is it? Kindly see one by one, all the things are okay only, yeah? All the things are okay only, is it? So now what will happen at here students? If we will remove the decimal, so it will come here 21 by 2 minus 10. 21 by 2, how much here students here? 10.5 minus 10. So 10.5 minus 10, how much it will come here? It will come here 0.5 ohm, 0.5 ohm, because internal resistance is there, is it? That means which option is correct? Option D is the correct answer. Now NEET 2013 question is this. Now students, let's see here. This is the very important question, Okay, see, discharging situations here. Terminal voltage versus current graph for a cell discharging through a resistance is shown in figure. Calculate EMF and internal resistance of the cell. Okay students, so here this graph we have to compare with one more graph we know very well. This is the I and this side voltage V, remember? And here what was this? Again I'm telling you, see here, this was the graph was there. Here interception was how much here? E by R. Here interception was E, remember? And what was the slope? If I will take here that this angle theta, now remember, then slope was tan theta is equal to minus R. Okay. So now students, if you compare very well, you can see this is the E, this is 4, and make sure what is the unit. Voltage this now, unit is very important. So E will come here 4 volt. Now we have got it. Second one, again you compare this side E by R, this side 8, but make sure unit also how much here? Ampere. So we'll write here E by R is equal to 8 ampere by default. No need to. Agar milliampere means then you have to write milli into 10 to the minus 3 and all that. Okay. So R is coming how much here? E by 8. So E is 4. This is the 8. So 4 by 8 how much here? Everything in SI 0.5 ohm. No? Because 4 by 8 anyhow 0.5 ohm only. Okay. So students, remember that here how beautifully we have done this question. It's easy only, but okay. No? We should know the concept. Now students, see this question is this. No? Let's see the question here. For NEET and J, important, very important, see, a cell supplies a current of 0.9 ampere through a 2 ohm resistor and a current of 0.3 ampere through a 7 ohm, The internal resistance of the cell is how much here? No? Okay, this C is not there. Okay. So students, if I will just write here, no? So see here. So first cell how much is given here? They have given here current, it has given here 0.9 ampere and internal resistance how much is this? You can see very well that 2 ohm. Okay. After that, if I write here in the second situation, what is this? The current how much is given here? See 0.3 ampere and internal resistance is how much here? 7 ohm. Okay. So two situations are there. And you know very well students here. No? You know very well here. You know very well. No? So you know very well, multiple times I told you. So see, I1 is given by EMF E by capital R plus R1. No? In a first situation, correct? I1, okay. E by capital R plus small r. Okay. So see, this is given here. Internal resistance they have given. Okay. Just one mistake. Through a 2 ohm resistor. Through a 7 ohm resistor. Mistake. What mistake is this? Students here, see, this is not R1, R2. Okay, this is the mistake happened here. Okay, what mistake happened here? This is the R1 external load. Here, what is this? R2. Okay, now okay. So R1 plus small r. And students, what is the I2? I2 is given by here E by R2 plus smaller. Discharging situation is there. E and small r is fixed, okay? And only the load is changing. So when the load will change, what will happen right here? When the R1, current I1. When R2, current I2. Load resistance is given, okay? So what we can write here, students? Both the sides we are going to equate capital E, because the capital E is the same only. So from here, capital E, how much I can write here? See, I1 R1 plus I1 small r. Okay, from here, with the help of this we are writing here. Okay, from here we have written capital E, I1 R1 plus I1 smaller. Here capital E, how much is this? We can write here, see, I2 R2 plus I2 smaller. Correct now? Both the sides capital E we have equated. Okay, so now students, we can write here, see here, this I1 R minus I2 R. No, this I have taken here, and here you can see here I2 R2 minus I1 R1. Okay, this thing is this. So small r we can write here what? I2 R2 minus I1 R1 by I1 minus I2. Now this is a general form that we have got it here. I2 R2 minus I1 R1 by I1 minus I2. Okay, now we'll put here the values and all that here. No? So I2 R2, how much is this? I2 R2 0.3 into 7. So 7 into 0.3 means 7 3 21. That means 2.1. Okay. I1 R1 how much here? 0.9 into 2. So 9 2 is 18. 1.8. 1.8 is it? And I1 minus I2, what is coming here? 0.9 minus 0.3. That means it will come here 0.6. Okay. Now we have to simplify this. 2.1 minus 1.8 means anyhow it is coming here 0.3 by 0.6. It will become how much here? 3 by 6. So 3 by 6 means 1 by 2, and here how much here? 0.5 ohm. Okay, so see in how much beautiful way we have got option B. Okay students, so I hope so this video you have understood very well. Keep studying, keep growing.